Hello students, today I'll start a very important chapter of class 12 inorganic chemistry part, that is coordination compound. That is very much important chapter for the competitive exam also. Now first, in the beginning you should know what do you mean by coordination compound. Coordination means, always remember, there should be presence of coordinate bond. Now, the compound basically formed by the combination of two or more stable molecular compounds, and the new compound which is formed that retain its identity in solid state as well as solution. Suppose here I am giving one example of a such coordination compound. The common name is known as potassium ferrocyanide, very important laboratory reagent that is used to detect different inorganic radical cations. It is used to detect the inorganic cations. Also that is useful for other experiments. This potassium ferrocyanide K4FeCN6, that is a coordination compound, and that is formed by the reaction between ferrous cyanide and potassium cyanide. Now when this compound is formed, if this compound dissociates, we will get basically two types of ions. Now just see, this is the cation part, that is K plus will form, and FeCN whole 6, that is the part. Here is the presence of coordinate bond, I will discuss later. Now just see, when it dissociates, we get K plus ions as the positive ion and FeCN6 ferrocyanide ion as the negative ion. Now that becomes 4 minus, and that is 4K plus. Why? Just think about simple compound. How can you write the formula of calcium chloride? Basically this formula comes Ca2 plus, this is the cation part, Cl minus 1, this is the anion part. Now when we write the formula, we just put the number here, just exchange. So Ca1, there is no necessary to write, and Cl2 because of this. And when this salt dissociates, we get Ca2 plus plus Cl minus 1, but to balance the electrical neutrality, we should give 2 before the Cl minus. Now just see, just like that, potassium, the oxidation number of potassium is plus 1. So when it dissociates, K plus ion will form, and here just think about the cross. So K plus 1, just think, plus 1 FeCN whole 6, 4 minus. So this 4 comes here, that means K4, and 1 comes here, that's why 1 is not written here. So in that way the formula is formed. We can write the formula, but after dissociation, when you write, to balance or to maintain the electrical neutrality, you should give 4K plus ion and 1 ferrocyanide ion. Now there are several important terms in the coordination to identify or to learn about the coordination compound. First, just see, suppose in the previous structure I have taken that K4 FeCN whole 6, or another compound K3 FeCN whole 6. Now just see, this part present in the third bracket is called the coordination sphere. Now just see, there is a presence of metal atom, and this is known as central metal atom, and these are adjusted, or these are basically present with this central metal atom by the coordinate bond, and these are known as ligands. Basically they donate the electron pairs, they may be neutral or negatively charged, whatever be the, but they will donate the electron pair through the coordinate bond to the central atom. Now this is not the total structure, this is a part. So that's why this is known as coordination sphere. And there are several types of coordination sphere. Here I am giving some example like cationic coordination sphere or cationic complexes. That means the counter ion of this structure should be an ion. Like that. Just see the complete structures. That is cobalt, NH3 whole 6, Cl3. So this is the cationic sphere or cationic complex. Now when it dissociates, we get, just see, 3 comes here, that means cross valency. So CO NH3 whole 6, that is 3 plus, and Cl minus 1 because chloride has the oxidation number minus 1. Now how many chlorides will form here? 3 chlorides. But when we write the formula, we have to cross the oxidation numbers only. So that's why after dissociation, we get the cationic complex, that is CO NH3 whole 6, 3 plus. And simultaneously this can be generated from different compounds where the counterpart is an anion. Now for anionic complexes, the counter ion part should be a cation, or normally we can find out they are the metals, but they are not coordinately bonded with the ligands. The coordinate bond is present, always remember, within the third bracket part, the coordinate bonds are present, and the ligands are basically donates the electron pair to form the coordinate bond with the central metal atom. And the central metal atom present here normally contains the variable oxidation numbers so that they can extend their valencies. Now I am just discussing about the anionic complex. Anionic complex, just see here, if you dissociate K3FeCN6, that is known as potassium ferricyanide, then you will get FeCN whole 6, 3 minus and K plus. Now just see, for the plus means plus 1. So plus 1, the 1 from K plus the 1 will go here and 3 will come here. So that's why the formula becomes K3FeCN6. So this part is known as anionic complex. And there are some compounds, the complete structure, there is no such cation or anions are present outside, and these are called neutral complexes. Neutral complex like NiCO whole 4, that is carbonyl, CO capital, both are capital. That was cobalt, the metal, and here central metal is nickel, and there is no such metal ions present or any anion part present outside. So here only the ligand makes the bond with the central metal, and the ligand is here carbonyl. And this type of complex are known as neutral complex. Ligand I have already discussed, they will donate the electron pair towards the central metal to make the coordinate bond. And there are several types of ligands, mono or unidentate. That means there is only presence of one donating site. That is, only one element can make from one site. So only one donating site is present, that is known as monodentate or unidentate ligand, like ammonia. That is a monodentate or unidentate ligand. Water. The coordinate bond will form from oxygen side. Here the coordinate bond will form from nitrogen side. So these are example of monodentate or unidentate ligand. In bidentate ligand, there are two donating sites simultaneously present, like ethylene diamine. Just see, this is the structure of ethylene diamine. And this 2 nitrogen acts or donate the electron pair simultaneously to a metal atom. Any one metal atom, suppose I am taking the metal by this notation, so it will make a coordinate bond simultaneously with the central metal atom present in the third bracket, that is in the coordination sphere. So this is why this is known as bidentate ligand, because donating site are two and that donate the electron pair simultaneously. And shortly this is known as En. So up to this part you learned. If you like my video, please subscribe my channel and watch the next upcoming videos. Thank you.